All right, so adding and subtracting rational expressions with different denominators. Now, we've done these before. We've added and subtracted rational expressions with different denominators. We understood that we have to get a common denominator. That's the idea. Once we have a common denominator, we add the numerators and put them over the common denominator. Now, the plus minus is not like the quadratic equation. It's just there to show addition and subtraction at the same time, right? So I'm just trying to show both at once. It's not quadratic. So if you look at this and you say to yourself, okay, I have an x in the left denominator and I have a y in the right denominator. Well, if I could figure out the LCD, the lowest common denominator, I'll work towards that. And that's what we did when we had numbers, and that's what we need to do now. So those of you that were smart, when we were doing numbers, you didn't simply use your stupid calculator button to do the fraction for you, but you figured out what you were doing. You figured out how to get a common denominator. You got that common denominator. You added the numerators, put it over the common denominator. So we do it with letters. So what's the big deal? So if you're looking at the rule, what would be the LCD of the rule? What would be the LCD of the rule? All right, lest you don't understand, let me give you an analogy, all right? So look over here. Don't write this. If you had a problem like this, 2 over 7 plus 3 over 5, you would all, I would be confident, know what the LCD is. And the LCD of that would be 35. Now, some of you don't like to talk, and that's stupid of you. Here we are at the end of the year, and you're still not talking, and shame on you, okay? But every time you say it, it helps, and it helps me to know that you know what you're doing. Otherwise, I'm going to have to call on you, and maybe I'll embarrass you. All right, I shouldn't have to say it at the end of the year. It's ridiculous. All right, 7 times 5 is 35. Okay, so just apply it to variables. It's no different. This was numbers. That's variables. So when we look at our rule, give you a second to think. On 3, this one you may not know, so you may not have anything to say. But I want you to tell me what you think the LCD is. All right, here we go. 1, 2, 3. XY. XY, of course, yeah. Right? Just like you did the 7 times the 5 for the 35, you're going to do the x times the y for an xy. So, you know, if we were doing this problem here, you would multiply this one by 5 over 5, right? So our rule, we're going to multiply the left fraction by what? We need a y on the bottom, and whatever we do the bottom, we do the same thing on top, right? Y over y. And we're going to multiply the right fraction by, right? And the x on the bottom, wherever we do the bottom, do the same thing on top, x over x. Right? And now we're ready to write the final rule. So we end up with AY. Again, I'm showing you addition and subtraction all at the same time with the plus minus. So you'll only have it with one. Either will be a plus sign there or minus. AY plus BX. Add the numerators and put them over the common denominator of XY. Just like we would have done with the numbers. We'll add the numerators and put them over the common denominator. All right, so that's the idea. Add the numerators, put them over the common denominator. Okay, so let's start with something that's relatively simplistic, and then we'll build from there. Again, it helps first off to understand what the LCD is. Some of you in your brain, you see it clearly, and you're clear on what the LCD is, and you're ready to roll. Others of you, you need to make sure that you know what the LCD is. So looking at this, we have 3 fractions, right? And that's fine. First plus the second minus the third. Not a problem. We still understand that we're adding fractions, so we've got to find a common denominator. Once we do, we'll add the numerators, put them over that common denominator. So that's what we're after. So to get the common denominator, it's always best to do the least or lowest common denominator. There are lots of common denominators. The lowest or least is the best one, because then there's no simplifying, or at least less probability of simplifying. All right, so you look at that and you figure out first off, what is the LCD? So that's your first thought. So, okay. So here, I'll show it to you in chart form. A 6 is a 2 times 3. An x is just an x. I got to put it in an x column. A 2x, I put the 2 in the 2 column and the x in the x column. And do you remember the LCD is represent each column once, right? 2 times 3 times x. LCD is 6x, yes? And again, I like this form because it's clear to see what to do to each fraction. All right, so now let's go ahead and deal with our 5/6. So remember, it's all about the bottoms, right? So I always start on the bottom. What do I need the bottom multiplier to be? It's got to be n x, right? Because I got to end up at 6x. And again, you can see, what is the 6 missing of the LCD? It's missing the x. So whatever I do to the bottom, same thing to the top. What is the x missing? It's missing the 6. And again, I'm always starting on the bottom because it's the bottom where it's at. I got to get a common denominator. Whatever I do to the bottom, do the same thing to the top. And finally, what is the 2x missing? And that is the 3. And whatever I do to the bottom, do the same thing to the top. It's at this point now, I'm just going to show the rule step. And it's to your advantage in these with variables to do so. So the first term is a 5x, right? You got that red plus sign between that and the second term. The second term is a 6. And then you got another red minus sign, and that last term is a 9, right? And hopefully you agree it's all over the common denominator of 6x. Make sense? Okay, for time's sake, when we multiply or divide rational expressions, we leave them factored. We're adding here. We need to finish adding the numerator. You can't stop here. You got to finish adding the numerator, and then when you're done, you got to look and make sure it doesn't reduce, because it might. Just depends. So finish adding the numerator. You end up with a 5x minus 3 all over your 6x. And now you got to say to yourself, does this reduce? We're definitely not going to make the mistake of trying to do the 3 and the 6, right? The 3 on the top and the 6 on the bottom, because we know that really that negative 3 is tied into that 5x, right? It's one quantity. And we can't do the x on the top from the 5 and the x on the bottom because that x is tied into the 5, which is tied into the negative 3. So there's no reducing of this one. But I did think about it, right? You got to think about it. So I added the numerators, put them over the common denominator, and we get 5x minus 3 over 6x. And there we go. So this one is similar. The only difference is we have binomials for numerators. So first off, let's think about the LCD. So what would be the LCD of this? I'll give you a second to think it through. What would be the LCD on this one? These numbers, you should be able to come up with it. So somebody raise your hand. What do you got for the LCD? Andrew? Yeah, 30 is the LCD. If you want to do it in chart form, a 6 is a 2 times 3, and a 15 is a 2 times 5. And you end up with 6 times 5 or 30, right? LCD. Okay. So, what are you going to multiply the bottom of the front one by? Lauren? By a 5, and whatever we do the bottom, do the same thing at the top. Key concept here to keep you from making a mistake. That 5 is times the whole numerator, right? So hence parentheses, because it's 5 times a y minus 1. And on the second one, hopefully you agree, we've got to multiply the bottom by a 2. And whatever we do to the bottom, we're going to do the same thing at the top. And again, I need a parentheses because it's 2 times the quantity. Now, let me just pause. Those of you that distribute way better if the number's in the front than in the back, you might want to stick your numbers in front. You just need to take the top one. If you're great distributing front, back, it doesn't matter, then leave it in the back. But I'm just telling you, be careful. All right, so I want you guys to go ahead and finish this. Going to add the numerators and put them over the common denominator. All right, so hopefully you determine the LCD. You need to multiply the left one by 3a on the bottom to get to 18a squared. Whatever you do bottom, same thing top. Right one by 2 to get to 18a squared. How many got that one correct? And those of you that missed questions. Kirsten.
For the thing, so the 3a is tied to n, so you can't reduce it.
Absolutely, you cannot. That's one quantity. It's a binomial. If you could factor out a common factor, you would be able to reduce with something on the bottom possibly, but there are no common factors. For example, if that was 3a plus 9, we could get out a common 3 and then do the 3 in the 18th, but not as a whole. All right? Other questions? Common denominator, right, is the LCD. That's what you're after. All right, nobody's asking questions, so those of you that are missing it and not asking questions, I can't help you if you don't ask. All right, so number 5. Same concept. Go ahead and solve that one. X minus 1 over x plus 2 minus an x minus 5 over x squared minus x minus 6. I'll give you a couple minutes to play around with it, and then I'll show you what to do. All right, let's see if you're working and thinking the right way. Notice that in each of the problems, I did write out how to get the LCD. And to figure out the LCD, each time I have a 2 times a 3 times an A. I have a 3 times a 3 times an A times an A. What I did was I factored, right? Did you factor? If you didn't, you don't know the LCD. If you didn't factor, you don't have the LCD. Because the LCD is each factor gets represented one time. Now, can you factor an x plus 2? The answer is no. That's just an x plus 2. That one's set. Can I factor an x squared minus x minus 6? Oh, yes, I can. Now, this is no different than when we had numbers. Didn't I factor the 9 into a 3 times 3? Didn't I factor the 6 into a 2 times 3? I did. I'm going to factor. Okay, this has to be a negative 5 and a positive 1? Surely I didn't do that. No. Good, because that would have been a pain. All right, always checking your middles. Negative 3 and a positive 2. Much nicer. All right, and that is the factorization of that. My outers plus my inners gives me my middle. So again, now when I list this one, I line up my x plus 2's, right, my x minus 3. And do you now believe the LCD is an x plus 2 times an x minus 3? Did anybody get that? Okay, numbers of you, good. Right, does it make sense, right? LCD from the factors. So now again, I'm just going to look and see my first fraction. What is it missing? It's missing the x minus 3. And again, I'm going to use a parenthesis here on the bottom. What is the top? Whatever I do to the bottom, do the same thing to the top. The second one has everything already. Do you agree? Okay. So that's good. At least we don't have to do something to both. Sometimes you do. This time we don't. Let me go higher for you guys. Okay, so now we got to be careful though. We're doing an addition problem. We have to add the numerators. And again, specifically subtraction, but same concept. So I can't leave this in factored form. This isn't multiplication, it's not division. We got to add the numerators up. So I first off have to multiply these two binomials. We know how to do it. Distribute. X times x is x squared. X times a negative 3 is a negative 3x. Negative 1 times x is a negative x. Negative 1 times a negative 3 is a positive 3. I now have this negative sign. Agreed in the top? I'm going to write it in red, and I'm going to use a parentheses because be careful. It's minus the x minus 5 numerator, right? So be careful, there's another pitfall because I have to subtract the whole numerator. So I need that parentheses because I've got to distribute that negative. What's our common denominator? X plus 2 times an x minus 3. Now I've got to finish up what the top becomes. All right, adding like terms. There are no other x squared terms, so I have 1x squared. Let's do the x's in black. A negative 3x and a negative x, that's a negative 4x. And when I distribute the negative, that's a negative 5x. And I hope you agree that we get a negative 5x. When I do the numbers, I have a positive 3, be careful, and a positive 5 for a positive 8. So x squared minus 5x plus 8 is my numerator. All of that over an x plus 2 times an x minus 3. Now we will leave the denominator in factored form for time's sake. The top is a what? Trinomial. It might factor. And the only reason we would care is if one of its factors were what? We only care if the top can factor into what? One of the bottom factors, right? Because that's, we could reduce it. Otherwise, it won't reduce, and what would it matter? For example, all right, this isn't the case. The top does not factor, by the way. You got 8 and 1, 2 and 4, and you can't get 5 in the middle. But let's suppose the top did factor. Let's suppose it factored into an x minus 1 and an x plus 8. Would that give us any advantage? Would we still be able to reduce? No, and so I wouldn't even care. I'd leave it that way. Right? Because it would have factored if it did. It wouldn't help me. Now, what if it factored to an x plus 2 times an x plus 8? Then the x plus 2's would divide out, and then I would care. But you got to look. You got to look. You got to look. You got to look. All right, so take what you learned on that one and apply it now on this one. Try to do 6, start to finish. Figure out your LCD. Figure out what you got to do to get both to it. Add the new. All right, keep working. If you're heading that way, I'm going to finish off here. Hopefully you figured out the LCD. Hopefully you noticed the difference of 2 squares, right, in that bottom left. Whenever I do the bottom, do the same thing to the top. That gives me a common denominator. Frozen. All right, thank you. All right, so the left was a difference of 2 squares. So the right one needs to be multiplied by an n plus 2 on the bottom. Whatever I do the bottom, same thing at the top. My numerator of 2n on the left, I've got my plus sign. And then as I distribute here, I get 6n plus 12 all over n plus 2 and minus 2. That gives me an 8n plus 12 over n plus 2 and minus 2. All right, can I factor out a common 4? Yes. What does it leave me, though? A 3. It leaves me a 2n plus 3. Is there any 4 all by itself on the bottom? No. Is there a 2n plus 3 on the bottom? No. So even though I can factor the top, because I know what it factors to, I'm not going to because it doesn't give me any advantage, though it does factor. We're going to do one more problem, so don't pack up on me. Was anybody able to get that one to the end? And by the way, if I were doing this on a quiz or test, I would write my final answer with n squared minus 4 on the bottom, because it just takes a second and we know what it multiplies out to. That's the way I would finish it. I wouldn't take points off because we're leaving things factored. But again, we know what that bottom is, and that's the way I would write it when I'm done. All right, try to find some space on your paper to do one more problem. I want to give you one more. If you notice, these last couple days, I'm trying to not give you a ton of problems. So make sure that you're focusing on the ones I give you, and you can see there's not a ton there tonight either. But I want to do one more. So I have 3y over y squared plus 7y plus 10. Leave some space. Then do your minus. And then the other numerator is 2y squared over y squared plus 10y plus 25. All right, so you got second one, 2y squared over y squared plus 10y plus 25. All right, you're adding. Your brain says I need a common denominator. How do I figure it out? Find the LCD. Multiply to get it. Add the numerators, put them over the common denominator, right? I'm going to be doing it as you do. If you need help, look. If you don't need it, don't look. Gotta try to squeeze this in. Cool. Can you factor a common y out of the top? You can. Will I then be able to factor into a y plus 2 or a y plus 5? The 5 has a possibility there with a 15. But 15's got to be a 5 and a 3 or a 1 and a 5, right? Only way you're getting a 15? 1 and a 3, or 1 and a 15, 3 and a 5. Would any of them leave me a 1 in the middle? 1 and a 15 won't, 3 and a 5 won't. So it had possibilities, but it won't factor into a x plus 2 or an x with a 5, and therefore I'll leave it that way. All right, same concept. Find the LCD, common denominator. Make sure you multiply out the numerators. Add them over the common denominator. Any questions on this one, Raquel? Yeah, y plus 5, thank you. I agree. what I have written there. No Kool-Aid for Raquel. She was actually paying attention, see? Very good. Awesome.